Hello guys, I'm back. My name is DJ, and in today's tutorial I'm gonna show you how we can convert this shader toy shader, right, into a SparkSL shader here on Meta SparkAR. Here you can see the example using SparkAR. Let me increase the screen here so you can see it better. And before we started, I want to recommend you this channel, okay? Here in the comments you can find the link for a tutorial where he teaches how to build this shader here inside shader toy from scratch. So he explains each line, each function. So if you're interested in that, learning that, you can open this link. So I'm gonna open here to show you. So here's the tutorial. I think it has 6 different videos where he's gonna teach you how to build everything from scratch. So I highly recommend you to follow this channel if you are interested in learning shaders, because he teaches a lot of things related to shader, okay? So for example, in this recommended video, he teaches how to create a camera in shader toy, okay? Here he explained the basics of creating shapes. So I highly recommend you to follow this channel if you want to learn shaders. But the focus of our tutorial is to convert a shader from shader toy to SparkSL, because that's what we use to make our filters. So enough talking and let's get started. Let's start creating a new project, a new effect. And the first thing you have to do is to save your project, okay? I'll save mine here, the drive home. And after you save, the next step is to like the video, comment, and subscribe to the channel, okay? So now let's go here to shader code assets, okay? And let's double click to open. As I mentioned before, I use Visual Studio Code as my code editor, but you can use anything you prefer. So let's copy this code here. Press Ctrl H, select everything, Ctrl C to copy, and Ctrl V to paste it here. Okay, so this code is a bit long, and the first thing we have to do is to add here our namespace, right? Using namespace std. So there are some things we know you have to change always, right? For example, here the variables here, iResolution and this frag chord, we don't have them on SparkSL. But before we change those variables, let me just save and show the errors we get. So let's go here to view and show console. Okay, let's save. And here you can see a lot of errors. The first one, the itime. We don't have this variable here on SparkSL, so we have to change all this itime. Have to replace it by, let's search for the itime, and we have to replace them by get time, okay? So let's select one itime here. I'm gonna press Ctrl D so you can select the next one, and Ctrl D again to select the next one. Okay, we only have 3, right? Yeah. So now if you type get time, you're gonna change all of them at once. Okay. So one problem is fixed. Let's see what's the next problem here, next error. Yeah, that's the iResolution. So let's change the iResolution here. So you can change here one by one, or you can just create our own iResolution. So let's create a vec2 variable, name it iResolution. It's gonna be equals get render target size. That's gonna return the size of our screen. Okay, that's why it's a vec2, because it's gonna have the x and y size. Okay, other thing you need to fix is here the UV. The way you get the UV on SparkSL, it's not like this. We have to use the fragment function, fragment, and then inside fragment we have to use the get vertex text chord function. Oops, this one here. Okay, that's another problem fixed. Let's see the next one. Oh, the iMouse. We also don't have the iMouse variable here on SparkSL. So what we're gonna do, we're gonna receive, okay, this information from an input that's gonna be our mouse position. So let's name it mouse position. And before I forget, this is another mistake, this input here. After the output, we're not gonna use this. So let's delete it. And let's create a variable here called iMouse. Okay. So it's gonna be a vec2 as well. Vec2, iMouse. That's gonna receive the mouse position. And we have to divide the mouse position by the screen size. So I'm gonna create this variable after we create the eye resolution. Okay. So let's divide it by eye resolution. Let's save again, check if we get new errors. It's not showing the errors, maybe need to save. But I think it's not updating here, so I'm gonna close and open again, okay? The project, when this happens, I always do that. So let's see now. Okay, yeah, I had to close and open again to update here our code. So the first error is because there's a typo. I typed target instead of target, so let's fix this pretty quickly here. Target. And the other error, it's also a common error that happens when you convert shader toy to SparkSL, because they declare global variables, okay? And the global variables here on SparkSL, they need to be a constant. So in this case, you're gonna have to move those variables, okay? The RO and RD, these ones, okay? They are global, they are outside all functions. So let's declare them inside our main function. And I have to check every single function that uses these variables, okay? So because we have to send them to the function. So we have to search for them. So Control F to search for these variables. This one's hard because it's only RO. And there are many words here with those letters. Let me just use RO equals, RO space equals. Okay. So the camera setup function use the RO, okay? It's gonna receive the position. And that's the only place. And let's see the RD. And RD as well. Okay, so let's do this. This variable position here, this POS, is only used one time here inside this function, the camera setup. So we're gonna bring this line to our main function, okay? And the camera setup, we won't receive this position anymore. It's gonna receive the RO, vec3, RO. So we have to send it here in the main function, where we call the camera setup function. It's here. So let's send the RO here. And before we send it, we have to give the position value to this RO. Okay, where is the position? Here. The position was declared here. And now the RD. The RD, it receives this value inside the camera setup function. So what I'm gonna do is I'm gonna make this camera setup function return a vec3, and I'm gonna give this value to our RD in the main function. So let's return this normalize here, and RD is gonna receive the value of this function here in the main function. Where is it? Here. So RD is gonna be equals the return of the camera setup function. Okay, and RD needs to receive this value here inside the main function because it's gonna be used again. Okay, for example here, you're gonna use this RD again inside the main function. And where else you're gonna use this RD and RO? Let's search again. RO dot no RO space. So this RO is being used here in the closest point. However, this function is already receiving those variables here, both RO and RD. So let's see where else. Here in the command setup, you already changed that. And here. Okay, let me see, search here for RO, comma. Okay. So it's being used here in the bokeh mask function, but it's already being passed here inside the function, so you don't need to change anything. Okay. So here inside the highlight function, we need to pass the RO here and the RD as well. Okay. And I think I got so many times. Okay. So inside the street lights as well function. And I think inside this environment lights function also. Okay, so in all these functions here, you have to send those values to them. So vec3 RO, vec3 RD. I'm gonna just copy and paste them here. The street lights and in the tail lights here. And in the headlights functions. Okay. So now we need to find where we are calling those functions. And I already know where we're calling it here in the main function. So here in the main function, we have to add the RO and the RD when you're calling the streetlights function, the headlights function too, the environment lights, and the tail lights. Okay. So I think that's all. Let me save again. Let's check. Okay, there's a new error. It says that there are too many arguments when we call the camera setup function. So let's see here. Oh, remember I delete this boss variable there. So I don't need this argument anymore. And save again. And the compilation finished successfully. I love to read that. So let's create here one rectangle to test, right? Rectangle. Let's increase the size. Let's create a material. Let's go to this material. It's gonna be type flat. Let's drag this texture input to our patch editor. Let's drag our shader. Oh, we're gonna need the mouse position here. So let's get the screen pen patch. Okay. And the 2D position we're gonna connect here. And now let's see. Okay, nothing's showing, but I already figured out why. It's because here in the output, I don't know how this is working here on Shader Toy with this value. Right here, on Shader Toy it's working, but this is the alpha. Okay, here's a vec4. It's gonna be a color, so it's gonna be a vector 3 here with the R, G, and B colors, right? And here is supposed to be the alpha. So this alpha needs to be 1 to be showing the screen, right? So let's set as 1. Let's save again. And it's here. It's here, as you can see. Let me resize here the window. But we're gonna notice something wrong. Our image is inverted. Okay, you can see the rain is going up instead of going down, and here the street lights are below the cars. So you can check again here. Here are like the cars coming in the street. Those top lights here are the street lights, and these red lights are like the cars in our side. So it's the back of the cars in our side of the street. And the raindrops are like falling down in the windshield of the car. This happens because the UV here in Shader Toy is inverted compared to the UV of the SparkAR. So I'm gonna show you the UVs of the Shader Toy here so you can compare. Oops. Gonna be UV XY 0 because the R and G channels only. Let's see now. Okay, here you can see the UV in Shader Toy. The UV was created here and it was shifted by 0.5. Okay, from the beginning to the end of the screen is 1, so it was shifted half of the screen. So the 0.0 here, they start, it's in the middle of the screen. And if we check here on SparkAR, let's do the same thing. I'm gonna just copy, paste it here. It's gonna be uv.xy 0.0. Did we do that shift here? Yeah, we did the shift here. Okay, let's see. See, the UV is inverted compared to the UVs here on SparkAR. You can see that the black part is at the bottom here and it is at the top here on SparkAR. So we need to invert our UVs only in the y direction. Okay, so let's get the UVY because we're gonna only invert the y direction and multiply it by multiply by -1. Let's save and see the result here. So I created here one error. Let's see what I did. Oh, this always happens. I forgot to put one dot here, so it was treating this -1 as one int instead of one float. So let's save again and see. Now it's inverted. Now it's exactly like the UVs here of Shader Toy. So sometimes, depending on the shader, we need to invert this the y direction. Okay. Okay. So now let me comment here. Last line and save, and we're done. Okay, we converted that shader into SparkSL here, and you can use this as a background. Okay, I love this effect of rain droplets here, and it works both in widescreen or in portrait mode here. Okay, so guys, I hope you have enjoyed this tutorial, and don't forget to give a like and subscribe to the channel. Okay, and also comment in the video so that YouTube is gonna recommend the video to more people. And if YouTube recommend it to more people, I will probably gonna make more videos about this topic. Okay, so see you in the next tutorial. Bye.